Somewhere in the silent blackness between galaxies, where light itself chooses the long way around, the universe unfolds according to rules so subtle, so quiet, most will never notice their trace. Now, as you settle, let us drift together into the mysterious realm of quantum mechanics, where reality's smallest secrets are written not with certainty, but with cool possibility, and where the deepest silence is thick with hidden motion. Consider for a moment the quiet space between atoms, those vast distances so much greater than the particles themselves, where emptiness is not absence, but a luminous stage upon which the strange rules of quantum mechanics quietly govern the motions of all that exists. In this gentle, hidden domain, particles shimmer between possibilities, never entirely here nor there, yet always influencing the world you know. Tonight, let your thoughts become as unhurried as a beam of light crossing cold, empty interstellar darkness, gliding through realms where waves and particles merge indistinctly, where silence is woven from probabilities, and the everyday world rests upon an unseen foundation of quiet strangeness. As you listen, you may find your mind gliding over impossibly smooth waters, following the gentle ripples and undulations of quantum phenomena as they shape the fabric of reality. Before we drift off, a quiet note: if these journeys help you sleep, subscribing is a gentle way to keep them coming. Now settle in, let your eyes grow heavy, and let's begin. Imagine the fabric of the universe, not as a solid, seamless cloth, but as an immense, dark sea, each point swelling and falling with gentle, invisible tides. A world where certainty is replaced by unfolding probabilities, and where the quiet dance of subatomic entities writes the deep textures of reality. Quantum mechanics, developed across the 20th century, describes a world so subtle, so profoundly unlike the everyday, that its truths seem almost impossible. And yet there is mounting evidence that, beneath the calm, visible surface of the world, particles slumber and awaken, according to rules stranger than any dream. In this elusive quantum landscape, what appears solid, a stone, a hand, a distant planet, is not formed of tiny solid spheres, but of regions where possibilities gather, where the whereabouts of each electron exists as a kind of gentle murmur, a whispered probability cloud, spreading softly through empty space. Now, the world of the very small is governed by the uncertainty principle, first described by Werner Heisenberg, which shows that the more quietly you listen for a particle's position, the more uncertain its momentum becomes, and vice versa, as if the universe forbids absolute silence and certainty at the smallest scales. Somewhere in the darkness, quantum superposition allows a single bit of matter to reside in multiple places at once, a notion so smooth and dreamlike that it slips through our habitual sense of reality, and yet it is repeatedly confirmed by careful experiment. Consider gentle waves gliding across a still pond. It is not one single place the water rises, but many, all at once, converging and interfering until the surface reveals a quiet pattern, shaped by every gentle swell that has touched it. Within the quantum domain, particles do not occupy definite paths. Rather, every route from one point to another is considered, traced softly by the mathematics of probability, with each possible path contributing a quiet voice to the final outcome. This is the foundation of Richard Feynman's path integral formulation, a way of seeing quantum phenomena not as abrupt, singular leaps, but as a gentle chorus of countless possibilities, humming under the static surface of what seems still and inevitable. Wave-particle duality, a phrase whispered quietly through laboratories and darkened lecture halls, tells us that the smallest things in the universe, photons of light, electrons within atoms, behave sometimes as smooth, undulating waves and sometimes as sharp, localized particles, depending on how softly one listens, on how the experiment is conducted. Somewhere in the undisturbed darkness, a photon will spread through two paths at once, only to reveal a single landing point moments later, as if probability coalesces into fact only when gently observed. This shifting, uncertain nature is no fleeting illusion. The double-slit experiment, a cornerstone of quantum understanding, has shown that even a single particle, sent gently through two narrow openings, will prefer not one path or the other, but a mysterious superposition of both, creating over time a pattern of light and dark, as if the quantum world is writing its own secret language across the void. Here, the act of observing changes the pattern, weaving consciousness gently into the tapestry of measurement. Somewhere in the vast, gentle quiet of a laboratory, a curious phenomenon persists: entanglement. When two quantum particles interact, their properties become linked so profoundly that, no matter how far they drift apart, across rooms or across galaxies, changes in one echo within the other, instantly, as if distance itself loses meaning at this deep level. Scientists describe this with quiet humility, calling it non-locality, acknowledging the delicate interconnectedness that knits the quantum darkness. It is not clocks or ordinary measures of time that shape the quantum domain, but rather probabilities, uncertain yet unbroken, gently unfolding across infinite possibilities. Consider the radioactive decay within ancient rocks, a process governed by half-lives ordained by quantum law, each atom ticking with silent unpredictability, revealing the eons through the measured release of energy, marking the quiet passage of time across whispered intervals. In the silence of the early universe, quantum fluctuations, small passing variances in energy, rippled across the cosmic void, planting the subtle seeds from which galaxies would one day swell and merge. Every leap of an atom, every shift in energy level within a cold gas cloud, draws from the same deep well of quantum indeterminacy, revealing an origin story not of certainty, but of possibility, chance, and the silent architecture of emptiness itself. The quantum world is not an empty vacuum, but a fluctuating field, a darkness teeming with virtual particles, constantly arising and fading, never quite crossing into lasting existence, but always shifting the balance, always whispering at the edges of what may become real. The energy of this vacuum, subtle yet fundamental, underlies everything, shaping the silence between atoms and the faint glow between galaxies alike. Somewhere in a silent lab, laser beams cool atoms close to absolute zero, pressing gently until quantum effects, usually hidden, become visible on human scales. At these temperatures, atoms surrender their classical identities, merging softly into a single coherent wave, known as a Bose-Einstein condensate, a sleeper's dream of matter, unified and still, every atom singing the same quiet note across a spread of space. In metals cooled beneath the frost of midnight, Electrons merge their behaviors to create quantum phenomena such as superconductivity, where current glides with no loss, as if friction is erased and matter remembers only flow, not resistance. The quantum world offers not only possibility in the abstract, but tangible effects that ripple up to shape the very world you touch and the wires that quietly carry the night's current. Across crystalline structures in the darkness, quantum tunneling becomes possible, allowing particles to pass gently through barriers that by any classical reckoning should be impenetrable. This elegant defiance of expectation is not reckless, but natural, as the boundaries themselves dissolve softly at these scales, and as electrons slip through energy barriers in cells and in modern technologies, weaving a delicate logic into both life and the digital world. Consider, for a moment, the silent gates at the heart of every microchip, where quantum effects dictate the whisper-quick jumps of electrons across impossibly thin spaces. None of the devices that carry voices or music or the quietly spoken words of science through the night would exist, were it not for these rules, written deep in the quantum world, and so encoded in the sleeping mind of the universe. Photons, the gentle quanta of light, are born in the glow of atoms and the shimmer of stars. They are not just particles, but bearers of electromagnetic force, moving silently across cosmic gulfs, sometimes interacting, sometimes slipping past with no trace. Each journey has no predetermined path, only the shimmering, probabilistic flow, as if light itself could decide, in the silence, how it will continue. At the edge of nothingness, the quantum vacuum hums with barely their energies, giving rise to the Casimir effect, an attraction quietly arising between two metal plates, separated by a breath, within perfect darkness. This gentle pressure is not the work of solidity, but of particles that exist, for the smallest moment, in between being and nothing, a gentle reminder that emptiness itself can possess texture and weight. Gravity, that most familiar and patient of forces, remains mysterious beneath quantum scrutiny. While Einstein's general relativity gently bends the fabric of space and time on grand scales, quantum mechanics resists simple union with gravity in the subtle darkness of the very small. Somewhere, at the limits of black holes and the whisper-thin beginning of the cosmos, lies a meeting place yet unknown, where these great theories might merge, quietly completing the universe's story. Even time, as it is softly marked by ticking clocks and circling planets, is undone and reimagined by quantum phenomena. At the smallest intervals, called Planck time, cause and effect dissolve into shimmering uncertainty, where the past and future are not always set, but gently formed by particles and possibilities, as if each moment must be chosen anew in the silent logic of quantum rules. Energy levels within atoms are not continuous, but layered delicately, like narrow terraces along a deep obsidian canyon, quantized and separated by precise intervals, so that electrons can only leap from one to another, emitting single photons of light, brief and precious, as they do. Every star across the midnight sky and every glowing screen in the darkness depends on this silent, stepwise transfer of energy. Somewhere beyond our tangible senses, quantum coherence forms a fragile, fleeting order, allowing particles separated in space to maintain a shared, silent rhythm, like dancers moving together in a great, dark hall. This coherence decays swiftly in the presence of heat, noise, or outside touch, as the ordered quantum silence dissolves softly back into the energetic murmur of the classical world. In the deep shadow between events, measurement and observation lie at the very heart of quantum reality. The act of observing, a photon striking a screen, a detector quietly registering a particle, does not merely reveal what is there. It shapes it, gently collapsing fluttering probabilities into quiet fact. Nowhere else in science is the border between what is and what is possible so thinly, so delicately drawn. At the threshold of possibility, the quantum world quietly influences your own existence. The sensation of warmth, the glint of a star, the memories refracted through sleeping thoughts, all are threaded with quantum events, silent exchanges of energy and momentum, woven with precision into the tapestry of experience. The familiar and the fantastic coexist, joined at every scale by the gentle insistence of quantum rules. Scientists do not claim to have unraveled the entire secret of quantum reality. Multiple interpretations, such as the Copenhagen interpretation, the many worlds theory, and pilot wave models, softly offer competing explanations, each weaving a different story about why the quantum world is so deeply strange. Yet, in the calm darkness of the laboratory, the mathematics unfolds with unerring consistency, even as the heart of the mystery remains hidden, just out of reach. Somewhere in the gentle hush of the night, the quantum world whispers beneath the familiar, giving rise to chemistry, to the structure of atoms and the unfolding of molecules, forming the foundation for the diversity and grace of all matter. The colors that softly entrance the eye, the flavors resting on the tongue, the lifeblood pulsing gently through the body, all these sensations are born in the quantum arrangements of electrons, energy, and probability. Your own mind, quietly adrift in sleep or in contemplation, is built upon the silent work of quantum mechanics. The flow of charge across membranes, the fleeting opening of atomic gates, the silent leaps of ions, all depend on the quantum world. Some scientists even wonder if consciousness itself is touched, in part, by quantum events, though this remains a theory, softly suspended between evidence and wonder, like a possibility in the darkness of the yet unknown. Quantum technologies are emerging from the realm of theory into gentle reality. Quantum computers, for instance, use superpositions and entanglement to perform calculations beyond the reach of classical machines. In the quiet chill of superconducting circuits or the hush of trapped ions, new devices begin to whisper with the possibilities of tomorrow, as the practical influence of quantum rules promises change as profound as any in the history of science. Consider how, through this gentle, unhurried tapestry, quantum mechanics leaves no corner untouched. It is there, in the decay of ancient isotopes, setting the quiet clockwork of ages past, there in the fusion within each sun, providing warmth to drifting worlds, there in the silence of semiconductors and the flicker of fiber-optic communications, letting distant voices reach you on nights such as this. And yet, with every new experiment, every photon measured, every atom cooled, a fresh layer of quantum strangeness emerges gently from the shadows, as if reality is shaped by accretions of subtle logic, softly building complexity from the silence below. The quantum world remains a realm of profound humility, a place where the simple desire to know must be tempered by patience and the willingness to listen for the faintest echoes of possibility. The paradox of quantum logic embraces not only uncertainty, but also symmetry and conservation, woven invisibly through every law that binds the world together. Charge, spin, and energy are always accounted for, balanced quietly in each quantum leap, as if the universe itself keeps an unbroken, silent ledger, ensuring that even chance is shaped by a bedrock of order concealed beneath the shimmering unpredictability. Somewhere, as the night wears on, your thoughts can drift softly over these distances, across the lightless spaces between atoms and the silent reach between stars, knowing that at every scale, the universe is governed by laws at once so precise and so mysterious, that even now, the full depth of quantum reality continues to rest softly, like undiscovered worlds at the edge of sleep. Let the peace of this cosmic order settle over you, with the comfort that, despite all its strangeness, the quantum world is not chaotic, but quietly lawful, every particle's journey constrained by gentle symmetries, every uncertainty balanced by silent regularity. Reality, under the watchful eye of quantum mechanics, becomes not a riddle to be solved in haste, but a boundless invitation to listen ever more deeply, to lean into wonder, to rest in the slow unfolding of knowledge. Within the gentle quietude of the subatomic realm, virtual particles flicker in and out of existence, as if reality itself is animated by a ceaseless, hidden tide that swells and fades across unimaginable distances, hushed and perpetual, their fleeting emergence a soft murmur beneath the solid world we sense. Scientists understand this ocean of possibility as the quantum vacuum, a fabric of space that is never truly empty, but instead continually stirred by the spontaneous birth and dissolution of energy's smallest whispers, all taking place in profound silence. As night slips further into its tranquil depths, imagine the phenomenon known as quantum tunneling, where particles traverse barriers as if thick stone were nothing but morning fog, their movement indifferent to the rigid boundaries that would confine more familiar matter, a process, strange and inevitable, that enables distant stars to shine and the breath of atomic energy to escape from deep within. In this hidden ballet, particles move through the impossible, guided by probabilities rather than certainties. Consider, for a moment, the serene indifference of entanglement to separation and distance, where entangled particles remain connected, their states bound together across gulfs no light could cross, as if a silent thread unites what seemed forever apart. This mysterious correspondence underlies a subtle unity, suggesting that, on the quietest levels of reality, distinctions of space lose some of their meaning, and the whisper of a change here may echo, instant and muted, in the vast stillness there. Somewhere in the spectral half-light of the universe, time itself becomes gentle and uncertain. Quantum mechanics allows that events need not always happen in a rigid order, but might drift, superposed, before unfolding into the fixed tapestry we perceive. In these unhurried depths, past and future blur into a shimmering haze, a phenomenon called quantum superposition of time order, where the sequence of cause and effect grows soft, and indistinct, like sand settling quietly at the bottom of a motionless pool. Throughout this grand, silent dance, the quantum world is guided by principles both abstract and beautiful: wave functions and probability amplitudes, mathematical poems shaping what comes to be and what never arrives. These intangible forms unfold in abstract spaces, their influence felt but never seen, weaving probability with the delicate patience of sunrise, lighting the edge of a vast dark plain, always present and always veiled. And as your thoughts float freely, consider the persistent mystery of decoherence, how the quantum dream of superposition gently collapses into the singular, definite world of shared experience, the process by which possibility surrenders to actuality. This yielding is quiet, subtle beyond measure, an invisible drift that restores the familiar outlines of reality, as if the universe itself takes a silent breath and settles gently into form. In the still shadows between particles, one finds the elusive principle known as superposition, where the most fundamental building blocks of existence are not bound to a single state, but drift peacefully across a spectrum of possibility, their every whispered probability merely awaiting an act of observation to become tangible. And so, the world is quietly painted not in bright certainty, but in overlapping waves of potential, each folding softly into the next, like the gentle blending of twilight into night. Consider, in these hushed interludes, the subtle presence of quantum tunneling, where barriers that appear impassable from a classical perspective seem to soften and shimmer, so that particles may, with unhurried grace, dissolve through the very walls that constrain them, sliding silently into places where, by the logic of larger things, they ought not exist. And yet, in this microcosm, such quiet transgressions are not only possible, but woven into the thread of reality. Drifting further along the tranquil eddies of scale, one encounters the enigma of quantum decoherence, a gentle process by which the fragile tapestry of quantum states begins to unravel beneath the gaze of its vast and indifferent surroundings, so that what once flowed in ghostly ambiguity slowly settles into the more familiar order, as though dawn itself coaxes scattered dreams into coherent morning light. And beneath these quantum rules, in the silences that stretch far beneath sensory reach, lies a principle known as symmetry, a serene orderliness threading through the laws of physics, ensuring that, no matter how chaotic the dance of subatomic things may appear, the universe remains, at its deepest root, harmonious, abiding by patterns as old as time and as soft as nightfall on silent water. As the quantum darkness continues to unfold, delicate and infinite, let your mind drift further, trusting that the world beneath the world is kind, ordered, and welcoming to curiosity, even as it keeps some secrets close. Somewhere in the gentle silence, you and the universe share this vast inheritance of possibility, uncertainty, and connection, so that, as you settle towards sleep, you carry with you the calm assurance that wonder and mystery wait patiently, like distant stars. Each night when the silence deepens, rest now in the stillness of the cosmos, enfolded within the quiet music of quantum rules. If you wish to continue drifting through the wonder and calm of our scientific universe, you are warmly invited to subscribe. Let your curiosity rest easy. There will always be more gentle explorations to lull your nights.